going to do a couple repeating decimal problems, and these are really kind of tricky problems, so I want to make sure you can kind of see how they work and then practice a few. So the directions say write the repeating decimal as a fraction, so 0.88888, and of course some of you know how to find this without doing any type of infinite geometric series work, so that's however going to be our focus, since that's what our focus is in this chapter. So I'm going to rewrite 0.8 repeating as something to see if you can pick out the pattern maybe. So if I take 0.8 plus 0.8 times 10% plus 0.8 times 10% squared plus 0.8 times 10% cubed, and I think you get the idea, and I want you to kind of stop and make sure that this makes sense, however. So 0.8 obviously gives me that first 0.8. 0.8 times 0.1 is 0.08. So if I take 0.8 plus 0.08, I'm going to get 0.88. This 0.8 times 0.1 squared will make this 0.008, and when added to these two, we'll get that third 8. So basically I keep growing in terms of that repeating 0.8. Well, now you can see, I mean, this goes on to infinity because it's a repeating decimal. The ratio that I'm multiplying all the time is 0.1, which is less than 1. So it is an infinite geometric series. Hence, I can go ahead and use the sum formula for an infinite geometric series, which says take the first term minus 1 divided by 1 minus the ratio. Well, my first term was 0.8. My ratio is 0.1, which is the 10%. And 0.8, 1 minus 0.1 is 0.9. And if I move both of those decimals over one place, right, I get 8/9. And 8/9 is 0.88888 repeating. So there's my repeating decimal as a fraction. Pretty cool. I just want to make sure you get one more. I'll go through this one a little bit quicker, but 0.63 repeating. So if I write that out as a sequence, it's 0.63 is my first term, and I group this in repeats, of course. So plus 0.63 times a hundredth. Notice it's a hundredth now instead of a tenth because it's repeating every 2 decimals. So if it were repeating every 3 decimals, this would be 0.001. And then I'm going to add on to that 0.63 times 0.01 squared, etc., etc. So very much like the previous, except it's the hundredths instead of the tenth. So because it's an infinite geometric sum, my first term is 0.63. My ratio was 100th. And of course, that's 0.63 divided by 0.99. And if I move both of those decimals over 2 places, I get 63/99. And then, of course, you want to make sure that if it reduces, that you do so. And both 63 and 99 are divisible by 9. So if I divide both of those by 9, that reduces to 7/11.